LeetCode problems. Today we're going to be solving 3 continuous problems, all very similar but differ in difficulty. Right, so the first one is ranked easy, so we should get through it pretty quickly. And it says, given an unsorted array of integers, return the length of the longest continuous increasing subsequence. And the subsequence must be strictly increasing, and it can be defined by 2 indices of L and R, where L has to be less than R, such that num at L and nums at L plus 1, all the way up to nums of R minus 1 and nums of R. It says here, so for each L has to be less than or equal to I, which has to be less than R, and nums of I has to be less than nums of I plus 1. So what that's saying is pretty much, given this example right here, an increasing subsequence of this array would be 1, 5, or 1, 3, 5, and another one would be like 4 and 7, right? So it has to be increasing from left to right, and a subsequence just means a part of this array. So we're trying to find the longest part of this array that has increasing numbers, and all the numbers have to be next to each other. All right, so to solve this, it's pretty straightforward. We're just going to iterate through the entire array and check if nums of I plus 1 is greater than nums of I, and if that's the case, we're going to increment a counter. And then we're going to do that for every iteration. And then if we run into this case where nums of I plus 1 is less than nums of I, we're going to reset the counter back equal to 0 or 1. All right, so first we're going to say int count equals 1, and we're initializing it to 1 and not 0 because the smallest length we can get is 1. Because if we were given an array of this, an array that looked like this, the longest increasing subsequence would be 1 because they're not increasing at all. It's just one character or one letter or number. All right, so we're going to say count equals 1, and then we also need to keep track of the max count, which will also be set to 1. And then we're going to iterate through the entire array, so just a basic for loop. And then we have to check if nums of I is less than nums of I plus 1. And if that is the case, we're going to increment the count by 1. And we want to keep track of the max count, which will be equal to the maximum of the count and itself. Just like that. That looks good. And then else, we're just going to reset the count back equal to 1, I believe. And that should be good. And then all we have to do now is just return the max count, and let's run it and see if it works. Okay, it works, and then submit it. All right, we had a Stack Overflow. Oh, I think I know the problem. The problem was that I forgot a -1 right here, and since we're accessing I plus 1, we need to make sure we're in bounds of the array, because once we get to the last character of the array, it's checking I plus 1, which doesn't exist. So we have to make sure that we're only looping towards this, the second to last element within the array, so we can check that I plus 1 is and stay within bounds, right? So let's run this again, submit it. All right, works. Pretty good solution. Not a lot of memory needed. Okay, looks good to me. All right, and then yeah, that's all for this problem.